Today, we will be solving examples of multiplying radicals, starting off with this expression, the square root of 18 multiplied to the square root of 27. The two radicals can be simplified, so let's start with the square root of 18. Let's find factors of 18 that has a perfect square number in it, so we can use 9 and 2, because 9 is the perfect square number. Now that we found 1, let's get to the square root of 9, which is 3, and we'll leave it outside the radicals' coefficient. Then we'll have 3 square root of 2. We'll do the same thing with the square root of 27. The factors of 27 that has a perfect square number in it are 9 and 3. Because 9 is a perfect square number, the square root of 9 is 3, and once again, we'll leave it outside the radical as its coefficient. Then we'll have 3 square root of 3. We can see that both radicals have the same index and are simplified. So we can apply the simple product rule for radicals, which states that the square root of a multiplied by the square root of b is equivalent to the square root of ab, where a and b represent non-negative numbers. Inside the radical, we'll multiply 2 with 3, which is 6, and we'll have the square root of 6, which cannot be simplified further. For the coefficients, we'll also multiply them, so 3 times 3 is 9, so the radical's coefficient will be 9. The final answer would be 9 square root of 6.
Moving on to the next expression, 2 square root of 3 times the quantity of 5 square root of 3 minus 4 square root of 7. We will be using distributive property in this equation, which states that a times b plus c is equals to ab plus ac. And if we apply that to our problem, we shall distribute 2 square root of 3 to the binomial inside the parentheses. We'll start by multiplying 2 square root of 3 to the first term in the binomial, which is 5 square root of 3. As Andrei discussed before, we will use product rule for radicals once again, which uses this formula. Square root of a times square root of b equals square root of ab. So we'll multiply the coefficient first. 2 multiplied by 5, which is 10. Then multiply the numbers inside the radicals. 3 times 3, so that we'll have the square root of 9. Together, we'll have 10 square root of 9. We can see that 10 square root of 9 is still simplifiable because 9 is a perfect square number of 3. So then, we'll have 10 times 3, which is 30. We will now multiply 2 square root of 3 to the second term in the binomial, which is negative 4 square root of 7. Don't forget to include the sign before the term. Using the formula once again, we'll multiply the coefficient first. 2 multiplied by negative 4, which is negative 8. Then multiply the numbers inside the radical. 3 times 7, so that we'll have the square root of 21. Together, we'll have negative 8 square root of 9. Remember to make sure all your terms are simplified before going further. Now, let's put the two terms together. We'll have 30 minus 8 square root of 21, and let's check if this is still simplifiable. There are no similar or like terms, so this is our final answer.
I will discuss the final expression, the quantity of 3 square root of y plus the square root of x. We can see that this expression is a square root of binomial, which means we can use the formula of a squared plus 2ab plus b squared. Let's start with getting the first term of trinomial by squaring the first term of the binomial. So we'll have 3 square root of y squared, which will be simplified to 9y because 3 squared is 9, and the square root of y squared is y because a square of a square root cancel out and you will left with radicands. Next, we'll get the second term of trinomial by using 2ab. We'll have 2 times 3 square root of y times square root of x. This is a simple multiplication of radical, once again, because we have two radical with the same index. We'll multiply the coefficients 3 and 2, which will give us 6, and we'll multiply the two variable in radical, so we'll have square root of x and y, putting for x first, so it's a alphabetical order. and altogether we'll have 6 square root of x and y. Finally, we'll have the third term of the trinomial by squaring the second term of binomial. So we'll have the square root of x squared. We have another square of a square root which we know will cancel out, and we will be left with a variable inside the radical, which is x. Now we've found all the terms of our trinomial. We'll put them together. Our trinomial will 9y plus 6 square root xy plus x. Let's check if we can simplify this. We cannot because there are no like terms anymore, so this will be our final answer.